Thank you, and thank you for coming and being here. This is very nice. I have a small device here. I will tell you shortly what this is. To change slide, I just click here, right? Yeah. All right. So I am Red. I have a startup called parametry.ai, and Celestical is one of our products. It's our main product, I would say. It's an independent cloud, so meaning it's not the cloud where we're using servers from AWS, Google, or Azure. It's independent, meaning it's our cloud. Our own servers across Europe in 5 different countries. So we call it above the clouds because it was built and it's built by space engineers. So above the clouds in space. And what do space engineers do and space researchers do is that they actually observe the Earth, you know. And I'm here explaining the green part of it. So here is methane emission in America. And you can see on the right what's in 2022, and on the left what's in 2019. So there's more methane emissions in 2022. So things are just growing in terms of greenhouse gas effects. Okay, this is data that comes from a satellite which is orbiting Earth since 2018. Sorry, and it's called Sentinel-5P. Those names are super complex. You don't have to recall. The thing is that it's using like 430 watts of power all the time on average. It's using a very green source, which is the sun, because it has solar panels. Everything is electrical in there. But the fuel tanks, which are used to move the spacecraft when it's needed, because you start to have traffic in space, or the satellites you have to avoid. So I'll just give you like a few numbers just to compare with data centers and other applications that will come up later. But it's 200 kilos of instruments, okay? When I'm talking about instruments, I'm talking about radar, cameras, and antennas and things like that needs to communicate the data and store the data, etc., etc. So if I had to put the cost per user benefits, so 150 million benefits from this data, because indirectly this is used for urbanization and many other things that impact our lives every day, it's less than €1. So it's what we call a scientific satellite. It's a big satellite, so meaning that it would almost englobe the whole room here. So it's a very big satellite. So this has a certain cost, but it's valuable for everybody. Okay, and it's generating 1 terabyte a day. I'm starting to touch the green part here. Is that 1 terabyte a day means that it's a little hard drive that we have to put there somewhere every day, or prepare the resources for that to be possible. Okay, and this terabyte has to be archived because scientists have to use that in the future when they invent new algorithms and reprocess the data. So we space engineers, when we work like that. At least that's what we think. We actually work like this with computers everywhere. So we're really used to actually make programs that will fit on a satellite. So if you've seen what a satellite is, like pretty much my smartphone with solar panels. So meaning I have to be very careful how much resources I will use. How much my for loop, my while loop will start to use when I do those things. What is processing? Is that going to work when it's embedded on the device? So we are very conscious coding. So meaning that everything we do on the code, we want to, you know, like when I'm coding, I'm having my teeth like that because the processor is running. That's what I mean. So the space satellites, they are also impacted by space weather. And today I have my gamma ray detector, because 2 days ago there were 12 events coming from the sun, and they're touching the Earth right now today, starting today. I'm just checking the radiation. Give me a minute. It's okay. Just safe. So all right, no problem. So if you see the light going down during the night, that's you know where it comes from. If you see a robot watching the talk, that's normal. But if you see northern lights coming from Frankfurt in the next few days, that's normal. So when we're doing that, in the meantime, there's other things that are happening between 2015 and 2023. Instagram, for instance. So I'm taking a typical example. Last year I did that talk, and I'm trying to be a bit smoother with you because I shocked people last time. So Instagram, you all know Instagram, I guess, social networking. In 2015, it was 300 million active users. now it's 1.3 billion active users. What does that mean? 1 billion active users that share their breakfast photos on the internet. Okay, so that's they're not sharing the numbers of photos anymore. So I had to predict. So that's why it's in italic here. So I just made a linear projection, typical one. So it would be like almost 200 billion photos and videos every month. Okay, what does that mean in terms of data? Who knows how big is a photo on the phone? You know, give me a number in terms of megabytes. Well, how much would you say? You really don't know, right? It's like, depends on the compression. Yeah, right? Depends on the photo, yeah, right? Yeah, so my camera is very bad, I would say, but it's still 9 megapixels. So each photo is 1.5 megabytes because it's compressed, okay, by JPEG, all those kind of things. If it's not compressed, it would be 27 megabytes, okay? It's a small video on YouTube, I would say, okay? I said in another word, 1 megabyte, it's 1 million characters. It's a book, okay? If you leave your phone with Wi-Fi on, okay, it will exchange 13 megabytes, about 10 to 20 megabytes with the network, just like that. Because your apps are saying, hey, I'm here, I'm connected, is the service okay? And those kind of things, sorry. So, and that means like 6 books every night. So if you want to make an ecological move during the night, just go off. Switch off the network at least. So that's for Instagram, the projection is like almost 700 petabytes. I can't even imagine what this is, and I don't know if anyone can. Who is using Instagram in the room? Every day? No, not using every day. Every day? Every 4 weeks. So if you send me a message there, you have to wait 4 weeks. So if this is Snapchat, this is Instagram, okay? Okay, Snapchat, why Snapchat put it like that? Because they erase the data. That's what they say, but that's what they say. So, but still from Earth, what from space, what we can see is that we see shapes on the ground appearing, which are mines, you know, like copper, other rare metals. And here it's blue, not because it's beautiful and nice and ecological, because it's chemical, okay? It's lithium, all right? All right, so what's the size of that? So it's satellite imagery, you have to be a photogrammeter. This is a road here, where the 18-ton trucks come. So you see the size of those big trucks here, and I try to see the size of the whole thing. So to expand that to the whole thing. So it's big. Why is this happening? 700 petabytes every month. Where do you think they come from? So we have to extract this. We have to extract those rare metals to build hard drives, to build processors, to build memory, etc. So, and every day, one of the US cloud, when I was in Silicon Valley, it was actually 5 years ago, said they needed 10 tons of materials coming to the cloud every day. That's as much metals and rare metals. So for 10 tons, and because if you read about mining, it's only 2% of the rocks that are the metals. So you need 500 tons to get those 10 tons, okay? And I'm not talking about the processing and all the things that's happening in the middle, which generate gases that would, you know, serve the global warming. You know, it's warmer, it's better. So what we want to do is like, we want to create incentives for impact applications. We don't just want to be another cloud, but have those incentives. We have better prices than all the others. And that's the first incentive. So we can say, okay, your application is good, it's responsible, therefore you have a better price. Okay? How we do that? We want to calculate that, how much memory you're using, etc., etc. But the thing is that, who is using Instagram already? It's like, yeah. We want to also create incentives for more responsible usage. Okay? So why do you use Instagram? You know, it's like, are you sharing selfies every day? You say, hey, I'm in the metro. Hey, we know you go to work. You know. I took a look, I did a pancake for my breakfast. You know, we know you eat in the morning. So what we do, we hire green IT human beings. So there's a lot of things that are happening today in terms of regulations, which are like the green IT part, which is like this Energy Star. You want to have less power-consuming processors, and et cetera, et cetera. But I guess in the equation of the physics of the impact that it can have is only 10%. The rest is the code you put on those things. And that's what we do. We actually reduce the tech stack so that our cloud needs less resources to serve better. So we are more performant with less resources needed. So, and that's why we want to push for creating those incentives for conscious coding. So you make a web app, that's fine. Show us how you do. We actually monitor the performances. We actually tell you like those changes you made improved, and we can actually at some point with AI advise you what to do. Because we want to avoid that. We want to avoid to have to run 4 metals just for, you know, pictures of breakfast, or having Wanda working on getting copper for all of us here that feeds our data center. So just take a deep breath. It's still okay. What we want to be, we want to become the what we call the AWS serverless killer. All right. Who knows what AWS is? Raise the hand. AWS is Amazon Web Services, and not everybody knows. That's a fact. So that's a US cloud. So meaning that most of the people here like host things on the US cloud, and they actually host your personal data. So institutions in the US can access your personal data if it's not encrypted, and that in 2020 it's very clear in GDPR in the new changes that it's not valid. There was a privacy shield that was protecting that, but it's not valid today. So at the same time we become that killer, we become Azure and Google killer because we're in Europe just by this first rule that we are GDPR compliant, okay, by design. We're also like serving the DORA Act, so the Digital Operational Resilience Act. So meaning that we've seen with you know, different foreign administrations that diplomacy can be very, very fragile. So meaning a country can cut the network from a day to another, from a second to another. And then as an institution here in Europe, you have to prove that you can switch to something else. And we want to help that. We want to help that. Coming soon. So there's a lot of things that, you know, when we buy food, it's green, it's bio, it's more complicated or more expensive. We want to kill that thinking. So green doesn't mean more complicated. So we're, for developers in the room, pip install, Celestical deploy. That's it. From your Docker Compose. From your containers, you go to the cloud. That's it. And it's also not more expensive. Because we're greener, we're using less things. You know, like I was thinking like the food is green, therefore there's less pesticide, you know, and that should be cheaper. No, because it's harder, because you have more loss and everything, okay, but that's not our case. This is IT. We have less loss. So we're actually repurposing hardware. We're doing those kind of things which are serving the green IT in many dimensions. And that's why we managed to be up to 70% cheaper than the other solutions, depending on the use case you have, of course. So we're not just a solution, we're trying to be a movement. So happy if you can you know, share your email so we can keep you posted on celestical.net. We're not really live yet, meaning public yet, but we have already users and paying customers because this is, you know, this is a high mojo product. Everybody needs the cloud at some point. So really happy to keep in touch and you know, hire whoever has those ideas of, you know, like really thinking green in that terms of computing, etc. Because this is really what we need as a thinking. So thank you, everyone.